Hi coders, CS Time channel here, and this video discuss about how to insert a node at the end of a circular singling list. If you wish to insert a node into a circular singling list, there are two possible situations of your singling list. The first situation is when your list is empty. The second situation is when your list is not empty. When your list is empty and you have a pointer named head, then your pointer will point to null like this. If you wish to insert a node that consists of data A like this and it's pointed by a pointer named temp like this, then you have to instruct the pointer belong to the head to point to the temp. The instruction will be head.next equal to temp. By giving this instruction, our circular singling list will look like this. The next job to do is to instruct the pointer belong to the head or temp to point to itself. The instruction is head.next equal to head, or you can also use temp.next equal to head because head and temp point to the same node. By giving this instruction, our circular singling list will look like this. When your list is not empty, like in this picture, you have one node that pointed by head pointer and you wish to insert a node at the end of this circular singling list, for example B that pointed by temp, then your first job is to assign one pointer. Here I use tail. I assigned it to point to head, so it will look like this. Next job is to instruct the next pointer belong to the tail to point to the temp. The instruction is tail.next equal to temp. By giving this instruction, our circular singling list will look like this. The next job to do is to pay attention on the pointer belong to the temp. We instruct it to point to the head. The instruction is temp.next equal to head. By giving this instruction, our circular singling list will look like this. Another way of doing this is like this. Once we instructed the next pointer belong to the tail to point to the temp with this instruction, which is like this. Now we can instruct the pointer of tail to point to temp. Tail equal to temp. By giving this instruction, the tail will point to the node pointed by the temp. The next job is to instruct the pointer belong to the tail or temp to point to head. By giving this instruction, tail.next equal to head. By giving this instruction, our circular singling list will look like this. Let's insert another node to give a better understanding. Assume I wish to insert C that pointed by temp here. Then the first job to do is by having another pointer which is tail here, and then we instruct the tail to move to the next node. Once we are in the last node, how do we know that we are in the last node? When that node dot next point to the head. Once we are in the last node, then we can instruct the pointer to point to the temp like this. Then we can move the tail pointer to point to temp like this, and then we can instruct the pointer of the tail or temp to point to the head like this. Let's see the Java implementation. In this video, I'm still using the same program that I used in the previous video. So in the previous video, I show you how to create a class named circular singling list that able to do the creation of circular singling list as well as able to do the traversing of circular singling list. And the last video show you how to insert a node at the beginning of circular singling list. Before we start writing the method on how to insert a node at the last of circular singling list, let's run this program first. As we can see here, this program able to do the insertion. At first, it can insert A in the beginning of the circular singling list and then B in the beginning of circular singling list. For the purpose of focus on the insert last, I will comment these two instructions. So the same with insert first or insert at the beginning of circular singling list, I will declare it as public void insert last. I will pass the parameter data here that I declare it as character, and then I have to create the node for my data. I use temp here as in our visualization. We will use this data here. So the first possible situation is our linked list is empty. We know that our linked list is empty when the head point to null. if our linked list is empty and we wish to insert a node, then we will just tell the head point to the temp. Once we are done with that, then we tell the head to point to itself. So head.next equal to head. Otherwise, it means our linked list is not empty. When our linked list is not empty, we need the help of another pointer. Here I will use tail. I assigned it to point to the head at first. Now we need to tell the tail to move to the last node. When the node.next equal to head, it means we are in the last node. So to do that, we need a looping. So we use a looping here, which is while, and then we check if tail.next not equal to head, it means we are not yet in the last node. Since we are not in the last node, we need to tell the tail to keep moving to the next node. Tail equal to tail.next. Once we are in the last node, which is we understand we are in the last node when that node.next equal to head. So when we are in the last node, we will quit the looping. Once we are in the last node, it's time for us to instruct the tail.next to point to the temp. And then we instruct the temp.next to point to the head. Finally, we instruct the pointer of tail to point to the temp. Once we inserted the node, then we will increase the length of our circular singly linked list. Let's see it one more time. So when you wish to insert a node in the last, then you pass the data here, and now we create the node for the data. The first situation of our list is empty. We know that the list is empty when the head equal to null. So we check first. If our head equal to null, it means our list is empty. Then we instruct the head to point to the temp, and then we instruct the head.next to point to itself. But when the head is not null, it means our list is not empty. We need another pointer, which is tail I use here, and we want the tail to traverse to the following node until the last node. How do we know that the node is the last node? When the node.next equal to head. So we can do that by using the looping. So we will tell our tail pointer to keep moving to the next, while our tail.next still not yet equal to head. Once our tail.next equal to head, it means we are in the last node. Then now we can instruct the tail.next to point to the temp, which is the new node that you wish to insert. And then we also tell the temp.next to point to the head, and then we move the tail pointer to point to the temp. Once we are done, we increase the size of the circular singly linked list. Let's try the program. We will call it first insert last CSLL dot the data here that I want to insert, say for example X. Let's run it. Since this is our first node, so X placed in the last node. If we try it one more time, I change it to Z. Here is the result. The Z placed in the last node. If we combine it with our previous method, which is insert first, so we run it. At first we insert A, and then we insert B in the beginning, A and B in the beginning, and then in the last X, and then again Z. If you learned something from this video, please subscribe and like for more videos. Thanks for watching.